Did you know that Bitcoin mining consumes more electricity than an entire nation like Argentina? But why does Bitcoin mining consume so much electricity? Is there an eco-friendlier alternative? In today's video, we will talk about consensus algorithms. We will explore two popular consensus algorithms used in cryptocurrencies, proof of work and proof of stake. We will delve into how they work and highlight their advantages and disadvantages. If you are not familiar with the terms mining or staking in relation to cryptocurrencies, I recommend clicking in the upper right corner to watch our previous videos on these topics, as it will help you fully understand the mechanisms of proof of work and proof of stake. What is a consensus algorithm? Consensus algorithms are the heart of cryptocurrencies. A consensus algorithm is a procedure that allows each participant in the blockchain network to reach a shared agreement on the state of the blockchain. In other words, this algorithm allows every participant in the blockchain to verify the authenticity of transactions and ensure that the blockchain is functioning correctly. In a centralized configuration, a single entity like a bank or a government has power over the system. In most cases, they can make changes as and when they want. In a decentralized configuration, no entity has the ability to make changes. How does the blockchain remain secure without any entity like a bank or a government controlling it? And this is where the consensus algorithm comes into play. In the world of cryptocurrencies, we need to distinguish between two consensus algorithms. One is the proof of work algorithm, and the other is the proof of stake algorithm. Let's start with proof of work, the algorithm that powers Bitcoin and many other cryptocurrencies. Proof of work requires participants, called miners, to solve complex mathematical puzzles using powerful computers. These puzzles are designed to be difficult to solve. Miners compete with each other to find a solution. After the first miner solves the puzzle, other miners verify if the solution is correct and then add a new block to the existing chain. When the new block is added to the chain, the process starts again. The miner who solved the puzzle first claims the reward, which is usually paid in the cryptocurrency of the blockchain. In the case of Bitcoin, the reward is paid in Bitcoin. The key idea behind proof of work is that the amount of computational work required to solve the puzzles makes it difficult for any malicious actor to take control of the blockchain. The network's security relies on the fact that most miners are honest and act in the system's best interest. However, proof of work has some disadvantages. Firstly, it requires a significant amount of computational power and energy consumption, which can have environmental implications. Secondly, as the network grows, competition among miners intensifies, making it less accessible for individual participants. Now, let's move on to proof of stake, an alternative consensus algorithm that is gaining popularity in the cryptocurrency space, with Ethereum being the most famous example. Proof of stake operates on a different principle. Instead of relying on miners and their work, it leverages the concept of staking. In proof of stake, participants, called validators, are chosen to create new blocks based on the number of coins they hold and stake. The coins staked during this process are used as collateral in case the validators fail to perform their duties correctly. The probability of being selected as validators to create a new block is proportional to the number of coins a participant has staked. This means that the more coins a person holds and stakes, the more likely they are to be selected. Proof of stake aims to address the energy consumption issue associated with proof of work. Since miners do not need to solve puzzles, the algorithm consumes much less energy. Furthermore, it promotes long-term engagement in the network, as participants have a personal interest in maintaining the value of their staked coins. In summary, proof of work and proof of stake are two different consensus algorithms used in cryptocurrencies. Both algorithms have their advantages and disadvantages. Proof of work relies on the computational work performed by miners, ensuring security through competition. Proof of work provides strong security but consumes a lot of energy. On the other hand, proof of stake relies on participants staking their coins, reducing energy consumption and promoting long-term commitment. Proof of stake offers energy efficiency but requires careful design to address potential vulnerabilities. We hope you enjoyed this video and learned something new. If you found it helpful, please click the like button. Subscribe to our channel and turn on the notification bell to stay updated with our future videos. If you have any questions or suggestions for future videos, please leave them in the comments. Thank you for watching, and we hope to see you in the next video.